Hi, I'm going to talk about the Julia sets and how they relate to the Mandelbrot set. The Julia sets are a series of fractals discovered by Gaston Julia. They are generated with the same recursive formula as the Mandelbrot set. But how could that be? Bear with me here. Here is a list of iterations of our formula. Here is the complex plane. For the Mandelbrot set, you substitute all of these c's for a number on the complex plane, such as this one. Then each result replaces z in the next iteration. If we see that the number keeps growing, our chosen point is not considered a part of the set, and is colored depending on how fast it grows. A number that stays bounded and doesn't grow, on the other hand, is considered a part of the set, and its point is colored black. We repeatedly do this, letting each and every point take a stab at being C, and the shape of the Mandelbrot set is generated. Zooming into it can lead into infinite arrays of complexity. Pretty neat. To infinite arrays of complexity. Pretty neat. Now, the Julia sets are made exactly the same way, but instead of substituting all c's with each number on the plane, we substitute only z sub 0. But then what shall we do with this c? No problem. We can just choose a different number to be c, such as this one. So we calculate and find out that this number stays bounded, so it is indeed in the set. Now, to calculate a different point, we keep c the way it is, and only choose a different number for z sub 0. This one is not in the set. If we keep doing this, letting each and every point take a stab at being z sub 0, we end up with this shape. If we zoom in, we find that it is a rather simple repeating pattern. Okay, let's do this again, only choosing a different value for c. We get an entirely new shape. So by choosing different values for c, vast varieties of different shaped fractals can be made, and every one of these fractals is considered to be a Julia set. Okay, so aside from the formula, how do the Julia sets relate to the Mandelbrot set? As you may recall, each point on the Mandelbrot set corresponds to a complex number, or a C value. So we can essentially take any point in the Mandelbrot set and use it to generate a Julia set. What's remarkable is that each Julia set has visual themes similar to the corresponding area of the Mandelbrot set. We can see here that gradually changing the C value can shift the Julia set, creating an almost kaleidoscopic effect. Let's zoom into this part of the Mandelbrot set. Take this point and use it to generate a Julia set. The Julia set looks like this, and we can see some obvious similarities. The very shape of the whole Julia set is depicted in the Mandelbrot set with striking accuracy. We can see this in a variety of different locations. What's even more interesting is when we zoom into the Mandelbrot set to find a mini copy of it. Since we are looking at something so tiny, the C values involved only slightly differ from one another. This makes the Julia sets appear to be the same everywhere in this mini Mandelbrot. But suppose we were to zoom into this Julia set. Look, a mini Julia set that does change, with only a subtle difference in C. What we have seen has made it quite apparent that the Mandelbrot set and the Julia sets are directly interrelated, even though at first glance they may seem like separate entities. For the mind open to metaphor, this phenomenon can be seen as akin to the nature of reality. Maybe things are more interconnected than they appear to be, the smaller things being intertwined with what fundamentally exists as a larger whole.